Okay, we're going to have a look at partial fractions. In order to sort out partial fractions, what we're trying to do is take a combined fraction and split it into smaller parts which can then be used later on. This will become particularly important when we get to the integration chapter, where we're often asked to start a question by splitting something into partial fractions and then integrating each of the individual parts. Before we can do this, we need to make sure that we know how to add algebraic fractions so that we can then undo the process with the reverse. So this comes in 4 stages really. First, we need to know how to add the fractions. Then the 4 stages of partial fractions are: either you have an improper fraction where the degree of the top is a lot bigger than the degree of the bottom, in which case we need to first use long division. We then have to check for any repeated roots. We then have to substitute any values to work out the constants which we've got. And if there was a repeated root, we then need to go on to the 4th step and check the coefficients of either x squared or the constant in order to be able to work out the final coefficients. So let's have a look at an example and see how first we can add 2 or 3 fractions together. We'll then move on to some partial fractions. I'm now going to try and add these 3 fractions together. In order to do so, you need to make sure first that we've got a denominator which is common. These 3 are all different, we need to make sure they're the same, and we can do that by multiplying them together. Note, occasionally you'll get a repeated denominator. Obviously you don't then need to multiply by that again. You can just have a single one in the final denominator. So multiplying these through, we end up with a denominator of x minus 1, 2x plus 1, x minus 3, all multiplied together as so. That's the denominator we're looking for. For now, I'm going to put that in each of the 3 fractions so that you can see the equivalent fractions and then see how they're multiplied together. Okay, we now have 3 denominators, all the same. All we now need to do is turn each of these into their equivalent fraction with the larger denominator. To do that, in this case, we've got x minus 3. We need to multiply it by x minus 1, 2x plus 1 in order to make sure we've got everything correct. So to do that, we have 4 on the top originally, and we need to multiply it by the x minus 1 and the 2x plus 1. This fraction is now the equivalent fraction of this one previously. So it hasn't changed, it just looks a bit bigger. We can do the same thing with these fractions. So the first one we're going to multiply by 2x plus 1 and x minus 3. Which is now the same in the equivalent form. And the final one multiplying by x minus 1 and x minus 3. We've now managed to get 3 fractions which are all the same as the previous fractions, except they now have the same denominator. This means we can now add them together. It's a bit like adding 3/7 and 4/7. You can then get 7/7 or 1. So, adding these together, the tops, the numerators, can now be combined into a single fraction. You'll notice that I have not multiplied out the brackets yet for the numerator, or in fact the denominator. The reason for this is there may be a minus sign, plus or minus sign here, and a plus or minus sign here, originating from the original fractions. If that's the case, the minus sign needs to apply to every single term within the brackets, and therefore you're advised to leave it until you expand the brackets before. So you combine the numerator first, and then you expand the brackets to ensure that the minus sign follows through in the correct fashion. So let's now multiply the brackets and see if we can simplify this. After quickly multiplying out the two algebraic brackets, we end up with quadratics. We can now multiply through by the constant terms. And I'm going to move my way back up to the board to see what's going on. So here we go. So here I have just combined the two x terms in each quadratic and then multiplied everything by the constant outside of the brackets. We've now got a nice long expression which we can simplify just by collecting up like terms. 6x squared, 2x squared plus 8x squared, that's 16x squared. We have plus 15 minus 8 minus 4, that's minus 27x. And then we've got minus 9 plus 6, which is minus 3. Minus another 4 is minus 7 over our denominator. Now you don't need in the exam to go any further than that. You've simplified the numerator, you've simplified the denominator. Unfortunately, this does not factorise any further. If it did factorise further, you may wish to factorise the top and see if there was any part which cancelled with the denominator. But in this case, there is not. So now we're going to move on and have a look at how we go the other way and split up fractions which are combined into their partial fractions.